Okay, welcome. We have a minute of hand that measures 10 centimeter around the axis and it rotates, and then the magnet and angle of the displacement is what we need to calculate in a 3-time interval. So we have the magnitude there that we have to calculate, and then from there we have the unit vector. So that's we need to find what's the unit vector, the vector that all constitute to. So we have displacement 1, which is a vector which is 10 centimeter, and then we also have a second displacement which is negative 10 centimeter, and that is that's y and that's j. So it's a 2-dimension vector. So change in displacement is going to be final displacement, which is displacement 2 minus the initial displacement, which is displacement 1. So that will mean we have negative 10 centimeter plus minus 10 centimeter. So remember, the final one is negative and the initial one is positive. So these are the coordinates that we have. We have 10 centimeter there on the I-axis, and then the J-axis, which is y. We have negative 10 centimeter, and then from there we need to find the absolute value of the change in displacement. So that will be the absolute value is the two coordinates that we have, that's negative 10 centimeter squared plus negative 10 centimeter squared. Okay, so that's changing, right? So that will give us 20 centimeter 200 centimeter squared. So it's 10 times 10 squared is 100 plus 2 of them is 200. So that will give us the root of, that's gonna be 14.14, and it's 14 because of the 2 points precision. And then we need to find B. So our B there, we have to find the angle. So the angle is 10, the inverse of 10 plus the ratio of the components of the displacement. So it's y over x. So our y is negative 10 and our x is negative 10. So that gives us 10, 1. So inverse of 10, 1, that's 45 degrees. So 45 degrees, we just check once again. Okay, that's 45 degrees there. And then we also know that we can also use the other side. So that's 90 degrees. So if you move counterclockwise, it's going to give you 90 degrees, negative 90 degrees. If you are moving the other direction. So to get there, it's going to be negative 90 plus negative going to be negative 90 degrees plus negative 45 degrees. So that's negative 90, negative 45, that will be negative 135 degrees. Clockwise. Remember, the original angle is anti-clockwise. So magnitude for the next hour. For the next hour there will be the initial displacement is going to be negative 10 centimeter J, and then the next hour is also going to be under J, which is going to be 10 centimeter. So the displacement is going to be that is from negative to positive, so that's going to be the change in displacement is final minus initial, so R2 minus R1 in terms of vector. So that will be 10 centimeter minus bracket minus 10 centimeter J. So it becomes 20, negative times negative is positive, 20 centimeter J. So that gives us change in displacement. Change in displacement is going to be root of 20 centimeter squared. So the root of 20 centimeter squared, the square cancels the root, and then we are left with 20 centimeter. And for D, angle of the next hour, angle once again is going to be theta is going to be inverse of 10, a bracket, the ratio, which is 20 over 0. So it's going to be invalid, so we're going to make it 0.00 something so that the calculator can do the calculation. So almost 20 divided by 0. So we have inverse 10, 20 divided by 0.001. Our answer is 89.99. So that's 90 degrees. And then from there we have, that's the magnitude of for the hour after that. That's a full sweep, which means it comes back to where it started. A hand resets or returns or rewinds to start point. So it means a start position, and then from there no displacement was made, so it's gonna be 0 magnitude. Okay, so the magnitude is gonna be on the angle. No displacement was made, no angle made, and that's 0 also. Thank you so much for watching, and this is your tutor Black Adam. Please don't forget to follow, subscribe. Any comment, leave below.